Line 22, 7b97z89, Harmonic, Magnetic, Dimple, Trap, Optical Dipole, Force, Laser Lights, 5G Wow Seti. There's the alien radio signal. Filmed September 19th. Line 22, 7b97z88, Quantum, Atom, Chip, Optic, Trap, Ballistic, Suspension, BEC, 5G Wow Seti. Yes, I have noisy neighbors that love to wear the shoes and thump all the time. RF, evaporative cooling, BEC formation, light sheet transition, phase space, density, dimple potential. So Google atomic pulse equations, and close PDF file results are on the blog. An optical dipole force on ladder-like 3-level atomic systems driven by chirped fused cycle pulse laser fields. There's the name of our scientist, and this is June 2012. The link is arxiv.org. And the keywords are optical dipole force to quantum atom optics experimental projects. That's from physics.uq.edu.au. So dimple trap. The dimple trap is a dual trapping geometry consisting of our magnetic trap and an overlapping light sheet that traps atoms using the optical dipole force. The light sheet is formed by a laser operating at 840 nm that is focused in one dimension using a cylindrical lens. The wavelength is chosen to be far detuned from the laser cooling transitions at 780 nm. The optical dipole force arises from the interaction between the induced electrical dipole moment of the atoms and the gradient in the light field intensity. For red detuned beams, the atoms are drawn to the maximum intensity of the light field, which is simply the focal point of the light sheet. The light sheet then acts as a dimple in the harmonic magnetic trap potential. Using the dimple trap, we have been looking at the dynamics of BEC condensation. With our magnetic trap, we first use RF evaporative cooling to the cloud to just above the critical temperature for BEC formation. The light sheet is then switched on, and we observe a transition to BEC without further cooling, which is a response to the sudden increase in localized phase space density given by the dimple potential. We have recently published this work in the Phys Reversion 2011. So here's a diagram, A and B, a dipole trap MT. Figure 3A is the dimple potential, which is on the left, formed to form overlapping cigar-shaped magnetic potential and dipole trap light sheet. And then B is the orientation of the dipole trap and magnetic trap MT to atom chip surface. From physics.uq.edu.au. Keyword atomic pulse equations is going to continue in the next 20 or so videos. Thanks for watching.